This is Brian our Lightman to talk to you about experiment number 2 of the CO2 fog generation. The conditions of this experiment are shown here. We're using a reduced stream rate. To accomplish this, I've used a restrictor valve as shown here. No changes were made to the reactor chamber. So with 1 pound of dry ice and 500 milliliters of hot water, we start the experiment now. Even with the reduced flow rate of 500 milliliters per 110 seconds, the reaction starts fairly quickly. At 30 seconds in, I decided to check the flow rate, and it's working fine. Overall, it's a reasonable amount of fog, but not quite as much as experiment 1. Between these two experiments, I've discovered that the fog is generated best when the water is flowing. One minute, 49 seconds, the water ran out. So we almost made it to 2 minutes of runtime, and now the fog will slowly degrade. It's 500 milliliters of hot water, 1 pound of dry ice. Some of it was powderized. We're at 2 minutes and 18 seconds, and it's not producing enough anymore. So I decided to give it another 500 milliliters of hot water and see if the reaction would continue. The additional 500 milliliters makes the reaction chamber a little susceptible to spillage after you reach a 45-degree tilt. 2 minutes and 52 seconds, more hot water. This new hot water will now combine with the cooler water and eventually start the reaction. The flow rate is 500 milliliters in a minute and 40 seconds or so. Reaction is starting to come up again. This is an additional 500 milliliters. You can see it boiling, bubbling there. Still depositing water into the reaction chamber. And that's the end of the water stream. 4 minutes and 45 seconds. Jostling it definitely increased the reaction. We're at 5 minutes. End of test. In conclusion, what we discovered is the slower stream rate did produce less fog, but it also lasted almost 2 minutes. I also discovered that dry ice evaporates fairly quickly, about 2 pounds overnight. To achieve a runtime of 2 minutes with sufficient fog, I'm going to have to use a 500 milliliter at 48-second rate, and I'll also have to use a higher volume of water, that is about 1,000 milliliters. End of experiment 2.